This video is on multiplying, adding, and subtracting radical expressions. A radical expression is an expression that contains a radical, such as a square root. The expression under the radical sign is called the radicand. For example, in the radical expression, the square root of 3xy, 3xy is the radicand. To simplify a radical expression means to write it without any perfect square factors in the radicand. For example, let's simplify the square root of 12. Since 12 is 4 times 3, I can write square root of 12 as the square root of 4 times 3. Notice that 4 is a perfect square because 4 is 2 times 2. So I can break up that multiplication. I can write that as the square root of 4 times the square root of 3. The square root of 4 simplifies to 2, so the square root of 12 simplified is 2 times the square root of 3. So when you're looking for perfect square factors, I'd like you to refer back to the list of perfect squares that you made at the beginning of this topic. To multiply two or more radical expressions, there's two ways you can do this. You can either multiply the radicands and then simplify, or simplify each radical expression and then multiply those. So for example, if I have the square root of 12 times the square root of 8, I can go ahead and multiply 12 times 8 and get 96. Then I can simplify the square root of 96, and the square root of 16, 16 is one factor of 96, so square root of 96 simplifies into square root of 16 times square root of 6. Square root of 16 is 4, so that's 4 square root of 6. The other way I could do it is simplify each of those separately. So the square root of 12 we saw simplifies to 2 times the square root of 3. The square root of 8 has a perfect square factor of 4. That becomes a 2. And then another factor of a square root of 2. So square root of 8 simplifies to 2 square root of 2. I can multiply the numbers out front. 2 times 2 gives me 4. I can multiply my square roots. Square root of 3 times square root of 2 gives me square root of 6. So either one of those methods works for multiplying two or more radical expressions. To add or subtract two radical expressions, their radicands must be the same. So for example, if I have 5 square root of 7 plus 4 square root of 7, I add the numbers out front and I get 9 square root of 7. The radicands have to be the same. For subtraction, if I have 10 square root of 14 minus 4 square root of 14, that equals 6 square root of 14. But remember, square root of 2 times square root of 3, I cannot combine those because the radicands are not the same. It's not equal to the square root of 5. Square root of 2 plus square root of 3 cannot be simplified. It's just equal to square root of 2 plus square root of 3. Sometimes you'll need to simplify the radical expression before adding or subtracting. So for example, 5 times the square root of 8 plus 4 times the square root of 18, well, I can simplify square root of 8 to 2 square root of 2. I can simplify square root of 18 to 3 square root of 2. So 5 square root of 8 simplifies to 5 times 2 square root of 2, which is 10 square root of 2. 4 square root of 18 simplifies to 4 times 3 square root of 2, which is 12 square root of 2. Now that I have the same radicand, a square root of 2, I can just combine the numbers out front. Let's try a couple examples together. It says simplify each radical expression. So the first one is the square root of 28. Well, I know that 28 has a perfect square factor of 4, so I can write this as the square root of 4 times the square root of 7. 7 is actually a prime number, doesn't have any perfect square factors, much less any factors. And the square root of 4 is equal to 2, and that stays square root of 7, so square root of 28 simplifies to 2 square root of 7. Square root of 80 times the square root of 75, those are kind of big numbers. I really don't want to do the square root of whatever 80 times 75 is, so I'm going to simplify each one of those separately. So the square root of 80 is the same as the square root of 16 times the square root of 5, because 16 times 5 is 80. Square root of 75 is the same as the square root of 25 times the square root of 3. So square root of 80 is square root of 16 times square root of 5, square root of 75, square root of 25 times square root of 3. This simplifies to 4 square root of 5, because the square root of 16 is 4. This simplifies to 5 square root of 3. And since I'm multiplying, I don't have to have the same square roots. I don't have to have the same radicand. So now I can just multiply the numbers out front. 4 times 5 is 20. I can multiply my two square roots. Square root of 15. So square root of 80 times square root of 75 simplifies to 20 square root of 15. Number 3, 2 square root of 3 minus 7 square root of 3. This is a subtraction problem, so I need to have the same radicand, which fortunately I do. So I just subtract the numbers out front. So 2 minus 7 is negative 5 square root of 3. And my last example, 2 square root of 48 plus 3 square root of 108. This I do have to have, since it's addition, I have to have the same radicand. So I need to simplify each one of these. So 2 square root of 48 simplifies to 2 times the square root of 16, which is the perfect square factor of 48 I'm looking for, times the square root of 3, plus, now let's simplify 3 square root of 108, 3 times square root of 36 times the square root of 3, because 36 times 3 is 108. This simplifies to 2 times square root of 16 is 4 times the square root of 3 plus 3 times the square root of 36 is 6 times the square root of 3, or 8 square root of 3 plus 18 square root of 3. And now that I have the same radicand, I can just add the numbers out front. That gives me 26 square root of 3. So in this video we took a look at how to simplify radical expressions and then how to multiply them and add them and subtract them.